Welcome to the lecture series of Embedded Systems and Programming, Unit 1, Introduction to Microcontroller. In the previous lecture series, we have discussed about the fundamentals of arithmetic logic unit and various types of microprocessor, microcontrollers, comparison of it, and in detail of 8086 microprocessor. In this lecture series, we will discuss about the microcontroller architecture. Yes, before getting into the architecture, we should know what are the basic components we have for a controller. First one is CPU, that is nothing but the microprocessor core that executes the instruction. So the CPU is same. Memory, as it is an extra part which is inbuilt here, and ROM, that is nothing but stores the program. RAM, temporary data storage during execution. EEPROM, non-volatile storage for user data, and peripherals, as the peripherals is also needed for the external interfacing. First one is timers or counters for time-based operations. ADC and DAC, that is analog to digital and digital to analog converters for interfacing with the analog signals. And next is communication interface, that is UART, SPI, I2C for the serial communication. GPIO, general purpose input output pins for interfacing with the external device. And finally, we have a clock generator which provides the timing signals with the help of the crystal oscillator. So we are taking the example of 8051 microcontroller, and 8-bit microcontroller is developed by the Intel. So it has a memory of 4 KB ROM, 128 bytes RAM, and 32 input output lines. So peripherals, that is two 16-bit timers and UART and 5 interrupt sources. So we have 5 interrupts here which will be discussed in later series. And in architecture, it is followed by the Harvard architecture, that is separate program for data and memory. So instruction set is, it has 111 instructions, that is which includes the move, add, sub, jump, etc. And modern microcontrollers, yes, we can consider as ARM Cortex M series, widely used in embedded systems, and it is a 32-bit architecture, low power. And ESP32S dual core, which has Wi-Fi, Bluetooth, and suitable more for IoT applications. PIC and AVR microcontroller popular for the hobbyistic and industrial applications. And next, we are going to discuss about the 8051 microcontroller, as starting from the CPU. This is a central processing unit, right? It is a same process which is performed in microprocessor, and now we have a clock generator. So for the purpose of clock generator, you can see a crystal oscillator circuit here with the uh, uh, 4 to 30 megahertz. And we have an interrupt controller. We have 5 interrupts, main interrupts here, and we have 2 input pins for the interrupt 0 and interrupt 1. And we have an on-chip ROM for the program code, which is also linked with both the interrupt and the bus control. And on-chip RAM also available. ETG, that is timer and counters, also available with the T1 and T0. And serial ports, that is for transmitting and revision, receiving. And apart from that, we have 4 input output ports, and these 4 input output either acts as an address data bus or data address bus. So 8081 pin configuration, as we discussed, we have the 4 input output pins starting from PO, P1, P2 and P3. And apart from that, apart from these 8-bit input output pins, we also have the other operations like receiving transmitter pin, interrupt 0, interrupt 1 pin, timer 1, timer 0 pin, read and write option. And here on the right hand side, you can see EA and BPP, IAE, that is address latch enable and programming option, and programming enable option. And we have AD0 to AD7, that is 8-bit address data bus, and we have 16 address bus. So we have totally 40 pins, and mainly we have VCC and also ground pin. So depending upon the instructions given to the processor, the input output pins acts either the input output pins or the programming status signals and or the control signals. So we have both status signals, control signals and input output signals. So depending upon the instructions, it will act accordingly. So we have the basic memory here, that is RAM, basic ROM, and inbit peripherals and inbit uh, Wi-Fi, Bluetooth applications, etc. So if we ask me whether which controller or processor is used, each processor, each microcontroller have a different uniqueness, where when compared to these three, 805, 885 is a basic processor best for the arithmetic and logical operations. Compared to that, 8086 has a unique feature of pipelining technique which helps in the fetching, decoding operations, better way to avoid the delay of fetching the instructions. And compared to the 8086, 8051 has an advantage of inbuilt memory and inbuilt peripherals. So each microprocessor or controller has an advantages and uniqueness. Depending upon the applications, we can choose the controller or microprocessors. So nowadays it has a advanced controllers like ESP, ARM, contact, Cortex, etc. So I suggest uh, each company chooses a controller or frames a controller depending upon their application. So the controller should be designed with the application specific rather than choosing on the generic controller. So in the upcoming series, we will discuss about the instruction sets and addressing modes and the instruction formats, which are the major concepts and designing and programming in this embedded systems. Thank you.